Today we're talking about roots, specifically nth roots. What do you think we mean by nth roots?
9, 10.
It means that that root could be any number. So last unit we were just doing square roots. Square roots are how many? 2. So in order to pull out a number, there had to be 2 of the same number, correct? Now with nth roots, what it means is that whatever number is here on the root, like if you had, let's say, a 3. So that means the cubed root of, let's say, I said 27. Well, in this case, how many numbers that matched need to be together in order to pull it out? 3. So this answer, if we broke this down, the answer would be 3. So I'm not circling groups of 2 anymore. This one I have to circle groups of 3. And if you have a 4th root, you would need groups of 4 and so on. Okay? So I'm going to make this so you guys can see a little better. Sorry. All right. This will make a little bit more sense later. But if n is an even integer, the value inside, if it's less than 0, you'll get a negative number, right? Numbers that are less than 0 are negative. And that means that you would have no real roots because anything that you had would end up becoming a I. Okay? If a is greater than 0, it's a positive number, you get 2 possible answers. Okay. If n is an odd integer, meaning like a 3, if you have a negative number inside, like for instance, if this was a negative 27, that does not become an I. The answer becomes just negative 3. So when you have odd roots, you can end up having a negative number. Okay? Because a negative times a negative times a negative makes a negative. Where when you have even roots, you have 2 negatives that you multiply, which become a positive. Do you guys get what I mean? Okay. All right. Find the indicated, and then also, if a is greater than positive or greater than 0, it's positive, you'll only have one root that's positive. So basically, when you have odd roots, you're only going to get one answer. It's either going to be positive or it's going to be negative, and you will not ever get any I's when you have odd roots. Odd roots would be 3, 5, 7, 9, and so on. Okay.
19, 21, 27.
Got it. All right, here we go.
Et cetera, et cetera.
Thank you. Find the indicated nth roots of example 1. So what they're telling you right here when they say n is 4 and a is 625, n is your root number and a is the number that goes under the root. So when I write this, this is going to be the 4th root of 625, which means how many will I need for a group?
4. So you
4.
get 5, right?
5 is correct. Okay, so 625 breaks down to 25 times 25. If you're ever not sure, whenever a number ends in a 5 or a 0, you know it's divisible by 5. So you can go that way as well. I remembered that 25 squared is 625, and then 25 is 5 and 5.
No.
What am I doing wrong?
You're doing it right.
Oh, okay. And so then I have 4 5s,
Don't mess up this one.
so my answer is
5.
5.
I screwed up.
Okay, example 2.
Wait, isn't it plus or minus?
Okay, and this, I kind of feel like maybe this is saying that you have a possible of 2 plus or minus answers. Did I make the root on this one?
Yes.
No, they're telling you about the root. So this one is just going to be 5. So you have like the possibility of having a plus or a minus, but this one is just going to be a positive 5. Are we okay with that? All right, yes. No. Because this answer is not. This original question was the 4th root of 625. The 4th root is totally different than like to a 4th power. It's like the opposite. Okay? All right. Example 2. How am I going to write this?
3 square root of negative 64.
So it's so we call this the cubed root of negative 64. Now remember, when you have an odd number here, your answer can be what? Negative. Chris, please put that away. The answer can be negative, okay? So I'm going to go ahead and just write the negative here so I know that that's done. And then break down the 64. No. 4 is probably easier. You could do 2s, but then you'd end up with 2 groups of 2s, and then you'd multiply to be 4. So we are kind of taking out the negative, but it's negative. It's not an I. Anytime it's an odd root, it's just going to be a negative. Even roots will come out and become an I. So even roots, if you have a negative, will become an I. Odd roots, you just bring out the negative. Because a negative times a negative times a negative will give you a negative.
So the answer is -4.
Correct. So 64 is 16 times 4, and then 16 is 4 times 4. So I have 3 4s, and I need 3 because it's a cubed root. So my answer is just -4.
Thank you, Ms. Alka, for explaining that so correctly.
Okay. All right. So now we're going to talk about radical notation versus rational exponent notation. Sorry about this shit. Let's put that parenthesis there. Okay, so radical notation is like where you have the square root of 2. Rational exponent notation, and most of the time we'll just call it exponent notation, you are taking this root 2 and you are writing it as an exponent. Well, in here, this 2 is to the first power, and if they don't tell you what kind of root it is, you automatically know that it is a square root. Okay, so this is a 2 right here. When you're changing this to exponent notation, you write this as 2. You write your power on top divided by whatever your root is. So the exponent of this number goes on top. The bottom number is your root number. So 2 to the 1/2 power and the square root of 2 mean the same thing. They're just written in different forms, right? Just like there's different languages. You can say the same word in multiple languages. It's like exponent notation and radical notation are kind of like 2 different languages. Same thing, 2 different ways.
So, the example would be square root of 5 to the first power?
Yes, exactly. So if we change example 3 to radical notation, it will be root 5, and this is a 2 and this is a 1. The thing is, and this is great to write it this way, but this one also is the same thing as root 5. Because we never have to write the 2 when it's a square root, right? And whenever you have a number to the first power, you never have to write the first power. So often you'll just see this, 5 to the 1/2, written like this. But I wrote it this way to show you. Does that make sense? But if it was any numbers besides 1 here and 2 here, you'd have to have the numbers written. Questions before we move on? Are we confused?
Yeah.
Yes? Do you guys, okay, so let's write this right here too. This is your power / exponent. And this number right here is your root. So the bottom number is telling you which number goes for the root, and the top number is telling you the exponent. And then this is the number that goes inside. It's like your base number.
I don't think they should have put the 2s as an example.
Oh, because there's too many 2s. Okay, so let's try another one. Let's say we have the square root of 3. Can you guys write that in exponent notation? Good. This will end up becoming 3 to the 1/2. Because if there isn't an exponent with 3, we know that it's automatically a 1. And then if it doesn't say the root, we automatically know that's a 2. So that would be 3 to the 1/2 power. If I had, let's say, 7 squared, the cubed root of 7 squared, how would you write that one in exponent notation? Good. It'd be 7 to the 2/3. 2, you keep the 2 high because it's your power. Keep it in the higher spot. And then the 3 goes below. And then they can go back and forth. And we're going to do some more examples here too on the next page. So, on example 4, you need to change that to radical form. So I'm going to give you a couple seconds here to try to move that to radical form.
Already did.
And this would be a great time for you to have out your whiteboards so I could see them. In fact, if you haven't already, will you get out your whiteboards? Some of you in front, I can see that. I believe so. My eyes are not great. Yes, that one's good. 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 Oh yeah, you can take stuff over there too. All right, so this one, the 3, is the 3 the root or the exponent? Good, the 3 is the root. So we have the cubed root of 5, and the 5 is squared. Okay? Also, this could also be written as the cubed root of 5 squared. Either way, those mean the same thing because you're squaring a 5 that's under a cubed root. So just so you know, both of those answers are correct. Okay, example 5. I'm going to give you another 10 seconds here to do example 5. Good. So this one we're changing to exponent form. Good. 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 Perfect. Okay, so this one is 5. My exponent, if they don't give me an exponent, we know that it automatically is a 1. So we have 1 as our exponent and 4 is the denominator. And that is my answer. Okay, do I have questions? Okay, these, they want you to evaluate them without using a calculator. Okay, so you have 4 to the 5-second power. How will I write this in root form? Because it's much easier to find the answer when it's written in root form sometimes than exponent form. Good, the square root of 4. And remember how I said you could write this with the 5th power inside or the 5th power on the outside. In this case, I think it'd be easier to have the 5th power out here because it's very easy to find the square root of 4. Don't you think? Yeah. And I can show you how both answers will end up the same. What is the square root of 4? 2. Okay. And then 2 to the 5th power is 32. This is one that you're going to see a lot in math, is 2 to the 5th power. So you'll hopefully end up memorizing that one. But 2 to the 5th is 32. Now, if I had written this as the square root of 4 to the 5th power, what does 4 to the 5th power mean? Okay, so we have the square root, and I'm going to write out 4 5 times. 1, 2, 3, 4, 5. Okay, how many do I need it for a group in this problem? 2, because it's a square root, right? So I have 2 4s, I have another 2 4s, and then this 4 can break down to 2 times 2. So when I bring that out, I have 4 times 4, which is, and 16 times 2 is 32. So do you see how you would get the same answer either way? So it's up to you, whatever makes the most sense to you, do it that way. Okay? All right. Any questions on example 6? Yes. Oh, I'm sorry. Right here, the square root of 4 breaks down to 2 times 2. So I had a pair of 2's that came out, and then to the 5th power, because we had our 5th power. Okay? Any other questions? Okay. Moving on to 7. There is a hint there. It says first make the exponent positive by changing sides. Remember that we can't have negative exponents. So this is really 9 to the negative 1/2 over 1. So if you have a negative exponent, what do we do? Good. So we take this whole thing, because this whole thing is being to the negative exponent, and we bring it to the denominator. The number that's with the exponent also goes. So that means I'm going to have 9 to the 1/2 power, and if nothing is left on top, what's there? A 1. Okay, and then how can I rewrite 9 to the 1/2 power?
3.
Yes, but if I want to change that to root form, how would I write that?
1 over the square root of 3.
Good. 1 over the square root of 9. Okay? And again, remember, if we don't write the 2, we know it's a 2. If I don't write a 1 as an exponent, we know it's a 1 as an exponent. And then 9 breaks down to what?
3.
So wouldn't it be 1/3?
So my answer is 1/3. Yes, that is correct.
So right first.
We have to work through the whole process. Not everyone can just get it. Okay? Yes?
Why do you move the 9 over? Because when we did it, we didn't move the whole number. We just moved the exponent to the negative.
This exponent is connected to the 9. Like whenever you have an exponent, it's connected to some number or variable. So if there was like another letter or something there, then you wouldn't have to move that part, but you have to move the part that's connected to the variable. I mean to the exponent that has negative. Okay. Example 8. How will I rewrite this?
Is the cube root of 81 to the negative?
Close. Which number?
The 4 on the outside.
Okay, so remember that this one's your exponent. This one is always, your bottom one is always your root. Okay, so when I write this, I'm going to write it as the 4th root of 81. And this is where it's your choice. Do you want to make it where 81 is cubed, or do we want to put the 4th root of 81 to be cubed? So I think it'll be easier to write this cubed there. Can 81 break down to have 4 things? What does 81 break down to? 9 and 9, good, and then 3 and 3. And we need 4 to make a group. So we end up with what? 3 to what power?
27.
Which multiplies to be 27. Very good. Okay, does anybody have questions right now up to this point?
Wait, I thought the 4 went like on the other, it went like inside.
No, this number is always telling you what root you have. Okay? And when we're dealing with these problems, it's easiest to put things into root form to find the answers. Okay, what's my issue with example 9? So how do I get rid of my negative exponent? Good. So we're going to take this whole thing, move it to the denominator, because this whole thing is being raised to that negative 2 power. So when I rewrite this, now I have the cubed root of 125, and that is now a positive 2 when I move it. Nothing's left on top, so that's going to be a 1. Can I break down the cubed root of 125?
Yes.
What does it break down to?
9.
Good. 25 and 5, and then 5 and 5, which makes just 5. So I have 1 over 5 to the 2nd power, which makes 1 over 25. I'm waiting.
Wait up. 1 over 5 because it's 2. And 1 over 25 because it's
So when it's a negative number, it's going to be negative.
You're thinking along the right lines. Okay, so remember that if you have an odd root, you can end up getting a negative answer. Okay? Even roots, if you have a negative inside, it becomes an I. So whenever you see a negative, check. Okay, is this odd or even? Odd. Therefore, I can go ahead and, like, if you want to put over where your answer is, it's going to end up being a negative. Okay? And then if you want to, like, not worry about it and you want to change it to a positive or something, that's fine. But we know our answer is going to be negative. And then cubed root of 8. Can that break down? Good. We get 4 and 2, which is 2 and 2, and I have 3 2s, which make a group. So that means I have negative 2. Now this is the tricky part. Negative 2 to the 4th power. Okay, so this came out as a negative 2, but now when I raise that negative 2 to the 4th power, what happens? It becomes a positive. And negative 2 to the 4th power, I heard someone say, is 16, and that is correct. Sorry. All right, questions?